morning, students. I am happy to see you all in this wonderful morning. So myself, I am Suresh, Assistant Professor, Department of Physics, Engineer Perumal, Manimekalai College of Engineering, Hosur. Today I am going to explain some important points regarding to solids and elasticity. So we all know that the matters are the important factor in this universe. The fundamental units of this matter is atom. So every matter in the universe is made up of different atoms, and atoms in the matters are interacting with each other in different way and yields you the properties of such kind of materials. So the interaction of atoms together is a very important factor. So based on the interaction of atom together, we can classify the matter into four groups. They are solids, liquids, gases and plasmas. If I see the interactions of atoms in four categories, the solids going to have very strong interaction together by the means of the different kind of bondings, namely covalent bond or metallic bond, etc. So this stability of such kind of phase makes these solids useful in our many industrial as well as engineering applications. So since we are replacing it in many areas, it is better for us to understand certain important mechanical as well as chemical behavior of the material. So on this basis, today we are going to discuss about the elasticity of these solids. Right. Now let me consider a body. Yes, solid body. It can be imagined as a numerous number of atoms interacted together by the imaginary force between them, what we are calling this as a bond. If this bond is strong, the material is considered to be very strong. If the bond is weak, the material is considered to be less strengthened. So this bonding between the atom plays a vital role in the mechanical as well as elastic nature of the material. Now, when a force is applied to this body, what will happen? This force will try to deform the body into different shape or change in dimension. So we can say that if the dimension is changed like this, what happens in the atomic level? So if I realize this as a one-dimensional chain of atoms connected with an imaginary string, a force is applied onto this atom will displace from the one point to another point, and due to the displacement of this atom, the position of the second atom also going to be displaced with respect to the previous atom. By the way, the distance between the bond length between these two atoms gets elongates. So due to this reason only, if I have a very long wire, if I try to pull it on one direction, this wire gets elongated. So the change what it is happening in the atomic level is the reason for what we are microscopically seeing in the outside. So this elongation or this expanding property is the inherent property of the material, and it is not going to be a common factor for all kind of material. It is a unique factor for each and every different kind of materials. Now, based on this behavior, when the force is acting on the body and its response, we can classify the materials into two types, namely elastic and inelastic. What do you mean by elastic? Now let me consider a system or a body. I am applying a force. What I am calling this as a deforming force. If the force is applied on it, it will result you in changed dimension or a new shaped material. If I remove the applied force, there may be two possibilities. One is the material which deformed may return to its original shape, or it may not go to any state and it will retain the state what it is being deformed form. If it is capable of return to the original shape upon the removal of the applied force, means this property is said to be the elastic nature and the material is said to be in elastic property. If such process is not happen, if this material is not able to return to its original shape, means such kind of material is considered to be a plastic in nature or inelastic in nature. That phenomena is called inelastic phenomena. So why it is returned to its original shape? Once again we can go into the atomic level consideration. Let me consider these two atoms. Now by applying the force from the outside, I am trying to pull the atom apart. So if I want to pull the atom apart, I need to do a work against this bonding between the two atoms. So work done from the force externally will be stored in the material or in the atom as a potential energy. Once this deforming force is taken off, and now at this point the atoms are in the higher potential energy situation. We all know that in the universe all system wants to be in the equilibrium state. They always want to have less amount of energy. Due to this equilibrium state, this atom will try to give out the energy what it is stored as a opposite force. By the way, this opposite force is the reason for regaining the original shape. So this force is called the stress. This force is called the stress. So we can define the first factor, which is very important for the explanation of elasticity, as stress. It is nothing but the deforming force or restoring force per unit area. Right? The stress may be in different forms depending on where we are applying. Let us consider three cases. Or first case is, let me consider a thin wire. If I apply the force along the natural direction, it will result in two kind of phenomena. One is, if the force is trying to expand this wire, means this wire may get elongates. If the force is trying to compress, means on opposite directions, it will result in reduction of length, and this case is called compression, and this process is called elongation. So initial length of this rod is say L, and after the force is applied, the new length of this rod is L2, L prime, means the change in length is to be delta L. So that is L prime minus L. Right? So the ratio between the change in the length to the original length, that is delta L by L, is called strain. Is called strain. For smaller amount of behaviors, these two stress and strains are proportional to each other. To understand the better relation between the stress and strain of a material, let me discuss the expansion or compression of a string with respect to the stress. Let me consider I am having a string which is originally at the length of L, right? I have applied no load. Now I have not, the load is the representation for stress, right? Now I am applying a smaller amount of load at the end. It results in the elongation of the string. Now the new length of the string is L prime, right? So here stress is causing you the strain. So the applied stress produces the strain, right? Similar way, if I add one more load to the system, this spring will elongate much larger. As a result of this increased stress, there will be an increased strain. So the strain produced on the material with respect to the applied force I can able to draw a curve called stress and strain curve. Stress and strain curve. So what I am going to do is, I am going to put the stress in the y-axis and strain in the x-axis. By using this plot, I am going to analyze the relation between the stress and strain. So initially I am applying the lower amount of stress and it produces the dimension change, and it is keep on increasing with respect to the strain is keep on increasing with respect to stress, and up to a particular point these two are proportional to each other. The stress and strain are proportional to each other. Say point A. After the point A, if I increase the stress further, it results in the higher value of strain. So my curve becomes like this. So at this point, the strain is not proportional to stress. So up to the point say B. So at the point A or at the point B, if I remove the applied stress, still this material can return to its original shape. So up to the point B, the material will expose you the elastic nature. If I further increase the applied stress, it results in larger amount of strain, and this becomes like this. After this point, the increase of load will not result in the elastic nature. So if the stress is applied beyond this limit, the material will not be able to return to its original shape. So from this point, the material start to behave like a plastic. Up to this point, this material behaves like a elastic. After certain point, if I remove, if I apply the stress further, it will result in the breakage of material. So there will be a limitation to apply a load to achieve the elasticity, and there will be a limitation to apply the load to avoid the material from fracture. So from this particular curve, we can get four important parameters. First one is the proportionality of the proportionality point. Second one is elastic limit, and third one is breaking point. So all these parameters, so the stress corresponding to the proportionality point, and the stress corresponding to the elastic limit, the stress corresponding to the breaking point are the most fundamental parameters we need to know when we are utilizing the material for proper understanding. So from this small presentation, we may understood how the elastic parameters can be better visualized by using this stress and strain diagram. So let me summing up what we have seen today. We have discussed about solids, and we have discussed about the elastic nature of the material, and we have discussed about certain terminologies like stress and strain, and finally we have discussed about the stress and strain curve. So I would like to thank one and all of you for the patience. Thank you.